happy people of the stats world? It's me again coming from my kitchen table. Our last few lessons have been on using z scores, and then we did a lesson on using a z table. Today we're going to put those two things together, actually finding a z score in order to find a probability on a z table. So you do want to have your z table out with you as we're going through examples because we are going to be using it. And the first thing we're going to do is just again look at what a z score and a z table means. So I'm going to pause here so you can pause the video and write these notes and examples into your notebook, and then I'll go through it. All right, so remember to use a z-score with a z-table, our probabilities. We were talking mostly about area with our z-table the other day, that it's the area to the left of that z-score. Well, remember that means it's the probability that is less than or equal to that z-score on our standard normal distribution, which remember has a mean of 0 and a standard deviation of 1. So we are going to use our tables today to figure out probabilities that are less than, so things that would be to the left of that, things that are greater than, things that would be to the right, and just like we did before, we will find probabilities of things that are in between z-scores. So first we're just given some z-scores to look at our table with so we can remember how to use a z-table. So again, your z-table, remember, looks like this. It has a positive side, it has a negative side. On the y-axis gives you your first decimal point. The x-axis gives you your second decimal point. So if we wanted to find the probability that a z-score is less than or equal to negative 0.40, we're going to go to the negative side, and we are going to find negative 0.4 on the y-axis. And then we're going to go over to 0.00 on the x-axis. And if we do that, it will give us the number, oops, I forgot to draw, 0.3446. And remember that that number actually represents the probability that you are less than or equal to a z-score. So this is the actual answer. So our probability that we're less than or equal to negative 0.4 is 0.3446. So again, if we wanted to do this again with a positive z-score like 2.41, we're going to go to the positive side of the graph. And remember, if we're on the positive side of the graph and we're finding everything that's less than that, we're going to have more area, so we're going to have a bigger probability. So if we go to 2.4 on our y-axis and we go over to 0.01 on the x-axis, the number we get is 0.9920. So again, we're trying to find something that the probability of something that is less than or equal to, and that is exactly what our table gives. So this is the probability that any data point is less than the z-score of 2.41. All right, finally, we're going to try an example where we have something that's greater than or equal to. So remember, if we're looking greater than or equal to on a table, we're looking to the right. And if we're looking to the right and our table gives us what's to the left, remember the entire distribution gives you an area of 1 or a probability of 100%. So we're going to take our 1 and we're going to subtract everything to the left of negative 1.26 to get the probability that we are to the right. So if we go back to the negative side and go to negative 1.2 and we go over to 0.6, the number we get is 0.0054. And if we do that subtraction, we will get 0.9892. All right. So that is just using the z-tables to find probabilities of random numbers. What we're going to do next is we're going to do an example that actually uses numbers and a meaningful mean and a meaningful standard deviation. All right, so on this slide is our example and the examples we are going to do. I'm going to go over each of these in the next. I have a blank slide after this so that I can show you the work. So I'm going to pause here again so that you can write this example down. And then once you have gotten it all written down, go ahead and start the video again. So this problem is about a seal sanctuary and the number of seals that can be observed at different times. This is observed normally, so we have a mean, so our mu is 73, and our standard deviation that they give us is 14.1. And we are going to use those numbers to find the z-scores for the following. So we're going to find the probability that we have at most 50 seals, the probability that there are more than 90 seals, and the probability that there's between 60 and 80 seals. And remember, the reason we're using a z-table is because none of these numbers, if you made the standard deviation, if you made the normal probability chart, would actually be perfect standard deviations away. So we can't use the empirical rule. So we're going to have to use our z-table. So we are going to do a few things. We're going to find a z-score for each. And then when we figure out that z-score, we're going to figure out which probability are we using. Is it telling us, asking for the left? Is it asking for the right? Or is it asking in between? So, all right. So the mean that they did give us, the mean they gave us was 73, and the standard deviation they gave us was 14.1. So the first question asks, what is the probability that there's at most 50 seals? So we want to know the probability that X is, and at most means there are 50 seals or less. So there are less than or equal to 50 seals, which is good because remember the z-score we're going to find and then put on the z-table is going to tell us the probability that it's less than or equal to that. So all we have to do is change this to a z-score and find the probability for that z-score. So remember, to find a z-score, we are going to take the value we're given, subtract the mean, and divide by the standard deviation. So if we do that, the value we're given is 50. Our mean we were given was 73, and our standard deviation is 14.1. And when you find the z-score, remember you want to find it to 2 decimal places because that is how a z-table works. So if you do the math here, you subtract the 73 from 50 and then divide by 14.1, you get a z-score of negative 1.63. So to find the probability that X is less than or equal to 50, we find the probability that a z-score is less than or equal to 1.63, which is the value that we get from finding the value for a z-score of negative 1.63. So if you go onto your table and you go to negative 1.6 on your y-axis, and then go over to 0.03 on your x-axis and see what number meets there, the number you get for the probability being less than or equal to 50 is 0.0516. All right, so the probability that you see less than 50 seals is slightly more than 5%. So this is our answer. All right, so that was the first example. The second example asks about 90. All right, so our second example was the probability that there are more than 90 seals. So we want the probability that X is greater than 90. So remember, when we convert to a z-score, it's going to give us the probability that it's less than or equal to 90. So in order to actually find the probability that we're more than 90 or we're to the right of 90, we're going to have to subtract our our probability from 1 to make sure we're telling the probability that we're greater than 90, not less than or equal to 90. So again, first thing we need to do is find our z-score. So we're going to take the value given, 90, and subtract our mean, 73, and then divide by our standard deviation, which is 14.1, which that will give us a z-score of 1.21. So to find our probability that we are greater than 90, we're going to find our probability of our z-score, and we're going to subtract it from 1, because remember, the table gives us less than or equal to, and we want greater than. So if we go to 1.21, so we go to 1.2 on our y-axis and over to 0.01 on our x-axis and see what number we get where they meet. That number is 0.8869. And so if we take 1 minus 0.8869 to get the probability that we see more than 90 seals, we get 0.1131. So a little over 11% chance that there are more than 90 seals. And that is our answer. So just like the day before when we were trying to find area to the left, we just took the area from the table. And when we're trying to find the area to the right, we had to subtract from 1. When a probability means greater than, that means we are to the right. So we have to subtract from 1. All right, our last example wants to know the probability that we have between 60 and 80 seals. So we want the probability that x is between 60 and 80. So remember last time when we were trying to find the probability in between, we had to find the probability for the z-score of the bigger one and subtract away the probability for the z-score of the smaller one. And that gave us our probability for in between. And a little picture here to help you remember why is because if we take the probability of the bigger one, which is less than or equal to that, and then we have a smaller number, we have that. So if we subtract away that red area, we'll only have what's left for the blue area in between. All right. So the first thing we have to do is we have to find a z-score for both of these values. I'm going to start with the bigger value because that is the probability we're going to find first. So I'm going to take the value they gave me, 80 minus 73, and I'm going to divide it by my 14.1. And that gets us a z-score of 0.50. And if I find my z-score for 60, my smaller one, I'm going to take my 60 minus 73, divide it by 14.1, and that gets me a z-score of negative 0.92. All right. To find my probability then, I have to first find my z-score. I don't have a lot of room to write, so I'm going to just write P for probability. I'm going to find my z-score for my bigger one. So for 0.50, you get a z-score of 0.6915. And I'm going to subtract away the probability of being less than or equal to my second z-score. So if I go to my table and I find my probability for negative 0.92, that is 0.1788. All right. So if I actually do my subtraction there, my probability of being between the probability of being between 60 and 80 seals is 0.5127, so a little over 51%. So this is just combining what we learned before of finding a z-score by taking the value minus the mean over the standard deviation, and then using that z-score on the table to find our probability. If it's less than or equal to, we're just going to use the value from the graph. If it's greater than, we're going